Right, today's session is the last basic Android session, okay? So we're going to, what I decided to do is give you a bit of a breather next week to get things finished off. So what I did, we had 6 sessions planned. I took half the content for the 6th session and put it in the 4th session, which is what we had last week, and the other half is going to this session. So I've got 5 sessions instead of 6 for you, and next week we'll just have a general sort of just-in-time catch-up, make sure everything's okay. Okay, so today we'll look at a couple of different subjects. We'll look at shared preferences, which is the equivalent of NS user defaults. If that makes any sense, but it should do. We're going to look at internal storage. We're going to look at SQLite database, which is the equivalent of core data. Because, to be honest with you, we can do all sorts of things with JSON files and XML files, like in iOS. But I might just show you how to use the database. Because it's simple, clean, uses SQL you already know, so it's much easier to work with an SQL database, isn't it?
So we're not doing dictionaries.
Well, we do dictionaries, but we just save them to a database. It's so much easier than because whereas in iOS development, the p-lists were kind of built in, and there's all functionality to handle p-lists. Believe it or not, Android doesn't have any capability to handle JSON data or XML data without third-party libraries. So when I put it together, I was showing how to import libraries, configure things, and I thought, to be honest with you, let's just use the database. It's much easier. Shut the door. Stand tall, we voice out. Okay, so this is the key. Now, the key is we need to make sure that whenever the user is finished with our application, it always backs up the data. Everything gets backed up to the database, everything gets saved. So this is the life cycle of an Android application. And as you can see, there's a lot of events being fired here. There's far more than we need to worry about too. Now, the most important ones are obviously the onCreate. Yeah? Remember that one? First session? And it gets fired 2 different ways. First, when the activity launches, and obviously if the activity gets destroyed or stopped, it's going to have to run onCreate all over again to create the activity. So that's the first important one. The other ones are this loop, inner loop here. This is where it becomes really useful. The on, pause, on, resume. Basically, whenever someone goes from one activity to another activity, it fires these 2 events. So when the activity appears on the screen, it fires on start. When it goes to the background or gets hidden or thrown away, it always fires on pause. So what we tend to do is we tend to put our data persistence code in the on pause and on start, on resume rather. Does that make sense? Because you guarantee every activity is going to go through that life cycle there in the middle. There's 2 points. So we're going to add our code to that particular point. And obviously, if it shuts down completely, if we've got loading data on resume, even if you shut the application down, it's still going to come around and hit on resume, isn't it? Every time. So that's a safe point. So every time someone switches activity, let's back up the data, let's keep it safe. Okay, so on pause, really simple. And what I always do, this is how I learned the system, is always mess with toast. Put some toast on and see if it works. So as you can see, on pause, no parameters. We need to call the on pause and superclass, and then let's just put a little toast on the screen to make sure things are working properly. So, but basically, if you put that code in, every time you switch to a different activity, you should see the toast come up on the screen to show it's gone to on pause. Okay, so now shared preferences. If I said shared preferences equals NS user defaults. Is that all I need to say about it? Yeah, I'll show you some syntax. It's exactly the same. I wonder where they got the idea from. So, of course, being Android and being Java, you have to do a lot more typing to get this to work. But it does exactly the same thing. So the trick here is we have to get a shared preference object. Okay, we have to have a shared preference object, and then we can set and get. That makes sense? So look at this example. Shared preference, preference name mode private. Private basically means no other application on the phone can see that data, which is pretty much we want that all the time, don't we? I can't imagine when we want to share this preference data. Once I've got that, I've got set text, look. I've got set text, and each one, okay, now this is an interesting one here. We've got a toggle button. What we're going to do is we're going to get the current value. That makes sense. So we've got set value and we've got get value. So here's an example of a get boolean, okay? And what happens is, with a get boolean, if it's a string, it defaults to an empty string. That makes sense, doesn't it? If it's a boolean, we can specify if it's not there, if it doesn't exist, what do we want to be true, what do we want to be false? That makes sense. So if it hasn't been saved already, and there's nothing in the shared preferences, we need to specify if it's going to be true or it's going to be false. For strings, it's easy. For numbers, it's 0. For strings, it's an empty string. For boolean, we have to specify what it is. I'll show you. Right. Okay, so there's another example. Look, shared preferences. Hi. Got this slide. So there's getting values. Look, settings get value string. Oh no, beg your pardon. It's different now. When you get the string or the integer, you can specify a default value. You see that? So string, integer, float, boolean, whatever. The second optional parameter is the default value you want if it doesn't exist. If you miss that second parameter off, it'll assign the default value for you. But this example, look. So settings dot get string. Get the value for the key of name. If it's not there, set it to an empty string, which is the default behaviour anyway. String value of settings dot get int. There's the key I'm looking up, and there's the default value. And the same, the boolean, obviously I've shown you that before. So basically, it's probably a good idea to set defaults, isn't it? So you've got a known state. Saving, slightly one extra line involved in saving. You have to have an editor object. So we've got our shared preferences. We create an editor, okay, which is a class method of the shared preference object. And this allows us to edit the settings. So you can see, look, shared preferences editor equals settings.edit. And this editor will allow us to modify those settings, those shared preferences. So put string, put int, put float, put bool, yeah? You can assign values to shared preferences. And for a lot of the time, that's probably all you're going to need to do, isn't it? Yeah, don't need to get any more complicated than this. Right, let's go to database. Internal storage I'm skipping because we'll cover that one later on. Right. Right, this is where it gets a little bit more complicated. Remember core data? And you had a series of classes associated with core data you had to implement. Well, in Java, because Java relies on inheritance so much, we have to create a special database class. Okay? So this is a class I've called DB helper, and it extends the SQLite open helper. And that basically gives us a way of manipulating our data. Now look at these methods. What's going on with ignore the first one for a minute. What do you think these two methods are doing? These are mandatory methods. What's this first method? When will that work?
When activity is loaded.
Even more specific than that, look what it's doing. It should look at the code, that'll give you a clue as to when this is going to work.
When you create the database?
Not quite, that is good, that's creating the database itself. What this is doing, it runs the first time we use this helper. In other words, we've never used it before, it's a clean application, clean install. The first time we use this helper, we want to be able to build our tables, don't we? So we're building our tables the first time this application loads. This is an interesting one, on upgrade. Notice how I've got a database version. That's really important. Because what I want to do is, if I update my application, I might want to add tables, remove tables, modify the content of tables, add fields and so on. So if it knows what the current version is that's installed on the phone, and it knows what the new version is it's trying to install of the app, you should be able to work out what needs to be done to the structure of your database. So it allows you to upgrade the application and modify the schema based on the new version. Does that make sense? And the important thing here is very simple syntax for working with a database. Notice how I've got an SQLite database. I create my SQL string and I simply exec SQL, and that just runs the SQL statement. So deep down, it's actually really simple, isn't it? Really simple database. And the database is this one, bookshop.db. That's my database. So in other words, I'm going to be creating a file called bookshop.db in my running application on the phone. It's a file-based database, like Access. Yeah, it's not like MySQL, which is a server database. It's a file database. The whole database is in one file on the device. Because if you think about it, relational databases are multi-user. If you've got a database on the phone, there's only going to be one person using this, isn't there? The phone owner. So every single phone on the market, whether it's a Windows phone, iPhone, Android phone, all have SQLite installed. It's pretty much just standard across all the different devices. And you work with core data. All that's happening is core data is a layer of objects over the top of the SQLite database. And the data types you can use, remember there were limited choices, weren't there, with core data, limited things you could store. They map directly onto the data types allowed in SQLite. So it's just a layer of objects over the top. If you really wanted to, you could actually run SQLite commands in iOS. You can run SQLite on iOS directly. But because core data sounds better, we use it, and because it's quite a nice framework. Right. Okay. So let's think about how we work with the database. We need two objects, two global objects for this to work. We need a database object. Makes sense, doesn't it? And we need a helper object, which we've just been talking about. With a database object and a helper object, we can do anything with SQLite. Obviously, the helper object, we need to create a new helper object, so we do that. We do that using the class method. And let's have a look at this one. Notice which way around this is going. We have a database and a helper. You would think that the database would load the helper, wouldn't you? That would be a logical way of doing it. It's the other way around. Look carefully at the code. To get our database object, we call getWritable_database from the helper. And that's important. That serves a couple of purposes. The first thing it does is, if the database doesn't exist, it will then run the right bit of code to instantiate the database based on its own internal code. That makes sense? It tries to protect the UU from the database. It also means the only reference to your database is in the helper. So if you change your database at some point, you don't need to mention the database by name at any point in your code. The helper contains that information. So it's kind of doing a similar thing to core data, isn't it, in terms of it's encapsulating the database of it. And once you've got your database object, there you are, database.insert. That easy. Database.insert. It returns a long ID because that'll be the primary key. That'll be the primary key of the record you just inserted. See how this works? Okay. Now, let's have a look at this. Right. In theory, you could work with your array list, couldn't you? And pull the data out of the database, stick it in an array list, and use the array list to populate your list views. Yeah, that's one way of doing it. Remember last week I talked about a second way of populating list views? I talked about the cursor. Cursor adapter? Remember I said there were two ways. There's an array adapter and a cursor adapter. Last week we talked about the array adapter, of how you could use that to populate the array list, and that would update the list view. This week we're going to talk about the cursor adapter. This acts as the interface between your list view object on your layout and your database. And it connects the two together. So it means when you start adding records to your database, or taking records away or modifying the records, it updates the list view. And conversely, if you delete from the list view, you can update the database. So it's exactly the same that we work with core data and table views. And we have that link, semiotic link between the two. So let's have a look at this one. This is how we select records. So there's my columns, there's my database, there's my cursor. Now the cursor is really good because what it does, it allows you to iterate and cycle through each of the records one by one. It maintains a pointer to one of the records. So let's look at this one. Cursor, database query. Don't worry about these. Cursor move to first. That moves to the first record in the result. Clear the books out. Okay, which is our list. And then we say, well, the cursor is not after last. Does that make any sense? Because when the cursor moves down, after it's read the last record, it moves to the position after the last record. So if it's after last, it means you've run out of records. It's moved to a non-existent record. String book, cursor gets string, books.add, or get string 1 is that one there. There's your primary key, that's index 0, that's index 1, that's index 2. Okay, so we refer to the columns by their index values rather than names. Cursor moves to next, that moves down to the next record. It then loops round, keeps trying to find more records, and eventually it's after last, it skips that block, closes the cursor, and closes the helper. So we've got a nice simple way of cycling through records and displaying them. Okay, does that make sense? As a simple database, SQL-like database. As long as you know your SQL, you should be able to build a helper class. That's your first tip. Create your instances of the database and the helper. Okay? You can insert records, and you can select records and display them in a list view. Okay? That's it when it comes to working with SQLite. Remember I said I split the week down the middle, didn't I? I split it into two halves. This is the leftover bit from when we talked about menus. Didn't quite fit into the previous session. So, context menus. Context menu is the one menu we didn't talk about, isn't it? In the previous when we talked about the menu systems. Traditionally, it's a long click. Now, interestingly enough, we're going to go back to our here we are, right. Context menu is simply an array of items. Now when we talked about strings, we talked about colours, we talked about dimensions, and they were all stored in resource files, XML files. You create an array exactly the same way. There's the name of the array, and there's the contents of the array. Okay, understanding this? So we create an array in XML, and then we load that XML array into our code to create a real array. Okay, just like we did with strings, like we did with values, dimensions, we did with colours, didn't we? We're going to store our values in an XML file. I tend to call it arrays.xml. That's not standard. You can put it in any of the XML files, because remember, that string array is the key. That's the name of the tag. So you can mix it in with your strings if you wanted, or you can mix it in with your dimensions or your colours. Because I like everything nicely organised and structured, I tend to keep my arrays in their own file. So I've got my string array, and then we've got this lovely. Oh, let's go back a slide. Sorry, missed a bit out. Register the context menu. any control you want to have access to the context menu, you have to call a special method called register for context menu. Okay? And you pass the name of the object you want to register. So I want to register my list view, which I called list view. I have to call register for context menu list view. And that means it will then respond to context menu presses. That make sense? If you don't put that line of code in, it won't respond to the context menu long. And traditionally, the register for context menu means if you press and hold, long click, it will pop up the context menu. So, this is the method you add to your main class. Now, this if statement, sometimes you don't need it. If you've only got one control registered for context menu, you don't need to have an if statement there, do you? Because there's only one control it could be. But I tend to get in the habit of checking the view IDs and see if it matches the control I want. Okay? And as you can see, this bit of code shows you how you can take an XML array and turn it into a proper array, a Java array. So adaptive view, adaptive context menu, menu info, set header titles, string menu items, there's my array, equals get resources, okay, dot get string array, and then r.array.options, which is the name I gave it. So it means rather than have to store your array contents in your Java controller, you can build your array in XML and then just load it in when you want it. And that's good practice. It keeps your resources away from your code. When you've done that, I'm afraid there's no simple way of adding it to the menu except the manual approach. Okay? So for in, so for loop. So I go through the items and menu.add and add the items to the menu. So that's quite useful bit of code to remember. That shows you how you can access arrays in your code from XML files, useful information piece number one, and also shows you how you can loop through those items and do something with them. And we build up this nice context menu. Okay, so on create context menu, okay, works in a very similar way to on menu. Remember the on create menu we did before? We had the menu button at the top. So you just override the default. So that's how we display it. How do we respond to it? On context item selected. It's always getting Objective-C length here, isn't it? Yeah, the method's getting longer. So this one, with a menu item, is passed through. So let's go back a slide. Remember we added menu.add, we added the items to it. When you click on an item, the item you clicked on gets passed through as a parameter. So int menu item index equals item.get item ID. Remember, when we created them, we created an array. Well, the keys of the arrays are integers, they're indexes, like it's an array, isn't it? So 0, 1, 2 and 3. So we can pull out the index. Now, look what's going on here. Where am I getting the value from? The array's in the menu, but where am I getting this value from? Look at this line. And this line. What am I doing to actually work out what's being clicked on?
Using the indexes.
Yeah, but where am I looking it up? I've only got an array in my code, haven't I? When I created the context menu, I created a local array, which obviously disappeared as soon as the method finished. Where am I getting the information from? Right, I'm going back to the XML, thanks Tony. So go back to the XML file. All I need to know is the item index. I know which index is being clicked on. I can then go back to my XML file, pull it out as an array, and then use the menu item index to work out which one's being clicked on. And I have to do it that way because when I created my string array for my menu items, I declared it inside the onCreate context menu, didn't I? which means it's a locally scoped variable, which means as soon as that method goes out of scope, or method closes, that variable goes out of scope. So it keeps my code nicely encapsulated. It's going to be quite a short session today, I'm afraid. So the idea is, from today's session, internal storage, forget about that for the time being, we'll come back to that after we finish this. Shared preferences allows you to store individual values in your Android application based on key value pairs. The SQLite database gives you a full relational database built into the phone. It makes no sense not to use it because it's there, it's easier than trying to cope with XML and JSON. I keep hoping every time a new version of Android comes out they'll have native support for JSON data. Because my next big topic with you guys is going to be working with web services, isn't it? And think about it. What format's the data in?
JSON.
So I'm going to be showing you how we can use external libraries to be able to read and parse JSON data. It's horrible. Sorry, I should put you off, should I?
Oh, William put up a sample code for data persistence, and he uses JSON adapters.
It's horrible, isn't it?
Yeah, it's bad.
You'll need to know that eventually,
Yeah.
but you can save yourself a few weeks and put off the dreadful day where it's an SQLite.
Okay.
SQLite is just, it's much easier to cope with than handling JSON data. I say eventually we're going to have to learn JSON, aren't we?
Yeah.
Because unless you want to completely recode your website to return CSV data, your web service, and that's what I never understood about the Android platform. These really fundamental concepts. You have to use third-party libraries for them. I never really got my head around why there wasn't native support for this. And you'll find that a lot of the time where you do something in iOS and it just kind of works, doesn't it? Just, you know, like JSON and, you know, you've got your plist data you can pull in, it's all quite easy and straightforward. Android is kind of more difficult because whilst I want to avoid making things too complicated, sometimes I can't avoid doing it. And that's why we did the iPhone stuff first, when we were still happy about things, and still focused, and the Android second. I'm working on a project at the moment with Bluetooth 4, working on Bluetooth 4 triangulation. And in iOS, it's 3 lines of code. In Android, it's 3 class libraries, which don't work. And you have to do all the mathematics yourself. Apple call it iBeacon, and it's part of triangulation using beacons is actually part of core location. Think about it. It makes sense, doesn't it? It's part of the core location library. And anything you can do with GPS data, you can do with Bluetooth data, Bluetooth beacon data. The methods are exactly the same. With Android, you've pretty much got to roll your own classes and write it from scratch and work out the algorithms for calculating triangulation based on signal strength. iPhone is easy. You've got there's a beacon. You've got very close, or adjacent, I think it's called, near and far, and that's it. all the tolerances, all the variations of signal strength, all taken into account. You simply walk along, and you've got three constants to choose from, and that's it. Android, I'm dreading starting on the Android version of this. It's horrible. No native support for it. So, I think you'll see the differences between the two platforms. Android, flexible, do what you want. Yeah, Java's a nice, easy language to learn. Downside is poor support for a lot of the core libraries you need. They don't exist. iOS takes a while to get your head around Objective-C. Mac-based, so you're a bit stuffed with it, aren't you, when it comes to hardware. And you've got less you can do within the app, there's less control. But you've got these features are built in. They're kind of baked in. I can't really say any more than that. I think you've just got to bite the bullet and have your legs sawn off or something. And go on with it. Or write Android code, whichever's easiest. How are you getting on with the Android stuff?
Yeah.
Near. Just near.
Yeah.
I'm just really pleased I didn't have to teach you all about the model view control and all that sort of stuff for this block as well. At least you had that knowledge when you went into Android. You know, it's one of those things. seriously, are you getting on with the first assignment?